Hi, and welcome to this video on solving trig equations with exact values while utilizing factoring. This is kind of the second video in a series I've made of solving trig equations with exact values. I'm assuming that you have a couple of abilities that I talked about in the previous video, real briefly again. Have to be fluent in the exact values chart for 35, 45, 60. Have to be fluent in the unit circle in understanding that it's the circle of radius 1 and any angle in standard position whose terminal side intersects the unit circle gives you an ordered pair where the x value is the cosine of that angle theta and the y value is the sine value of that angle theta. Okie doke. So you also need to be very fluent in the all students take calculus chart, which will tell you the where to locate positive values for trig functions, and then if you know where the positive values are, you should commensurately know where the negative values are as well. Okay, so let's get to work. I'm going to do some examples here that are going to involve factoring. I'm just going to do some that involve some basic factoring techniques using greatest common factor. You have to be fluent in all your factoring techniques. If you're in this end of the pool where it's pretty deep, you got to be able to factor. That's more of an algebra 1 and 2 skill. So I'm assuming your factoring's decent. Okay, so let's take a quick look at how to factor this problem. We notice that it has two terms that have a common factor of sine. So I think I'm going to factor out a sine theta, okay? And then the remaining factor, sometimes called the buddy factor, will be sine theta plus a half equals 0, okay? Now, why do I factor? Well, it's the same old song from Algebra 2. It helps me solve, especially if I have an equation that's equal to 0. Because now I have two factors, a and b, whose product is 0. So that means that a is 0 or b is 0. So I'll just set that up and get us to take a look at that. You know that the sine of theta is equal to 0 because that's the first factor. Oh, excuse me, wrong tool. Sorry about that. And we say that the sine of theta is 0 because that's the first factor, or sine theta plus a half equals 0. So I'm splitting with the zero product property. So essentially I'm solving two problems, okay? So now I'm going to apply my techniques that I did from the last video. First is I'm going to isolate the trig function in this first equation, sine theta equals 0. Well, I already have. I note the fact that the output is 0, so I'm not using the specials chart. I'm going to use the unit circle. And you have to, again, be fluent in realizing that the sine implies the y value. So we're asking, where is y equal to 0? Okay, so that means go right or left, but don't go up. So that is going to give me a value here at 0 degrees, 1 comma 0, and at pi radians, excuse me, I should have said 0 radians, because we're in radians, right? Okay, so we see here that two of my values that I want are theta equals 0 and pi. And again, that's only from the first equation that I'm solving. Okay, so in the next equation, same kind of strategy. I'm going to get the trig equation by itself by subtracting a half. And I notice here by the fact that we have a half, that's in the chart. It's not on the unit circle. So the strategies I need to apply there are to fuse together the desired sign, okay, with the desired reference. Okay, so I'm noting what here? That I've got a sign value that's negative. So I don't want the first quadrant. I don't want the second quadrant because sine is positive in both of those. I do want the third quadrant because if tangent's positive, sine will be negative. I want the fourth quadrant because if cosine is positive, sine will be negative. So now I've got to use the reference angle using the numeric portion of that value, and I see that sine is a half. So that is going to give me a reference theta of pi 6. So I'll draw my pi 6, and then realize again that I'm not using it though, because I don't want that. I don't want that quadrant. Okay, so I'm going to draw two reflections of that angle. First one in quadrant 3, next one in quadrant 4. So the theta values here that I want are going to be 7 pi 6 in the third quadrant and 11 pi 6 in the fourth quadrant. So I get 4 answers here. 2 from the first factor, 2 from the second factor. And again, I needed the factor to start. So let's take a look at another example. Okay, again, I'm just trying to keep the factoring light. That is greatest common factor problems. Okay, you'll see. But you need to be able to factor fluently here. Okay, so I got cotangent squared theta minus cotangent theta equals 0. Okay, I'm going to solve for values of theta in the interval from 0 to 2 pi. So again, I notice it's a greatest common factor problem. So I will factor out the cotangent theta because it's in each term. Okay, and then I'm going to take a split of those two factors. The first one will be cotangent of theta equals 0, and the next will be cotangent theta minus 1 equals 0. Well, again, now if you look at both these equations, we're going to get the trig function by itself here and know that we do. Cotangent of theta equals 0. Well, that is not going to be in the specials chart. I got to deal with the unit circle for that. Okay? So, have to be fluent in the rules, and you realize that cotangent of theta is equal to x over y. So for x over y to be 0, x has to be 0. So I'm going to look in my diagram for where I get x is 0, which means don't go left and right, but you can go up and down. So that is going to be at pi halves and 3 pi halves. Okay, so I know that theta is going to be pi halves and 3 pi halves to start. Again, that's just from the first equation. I move to the second equation and realize when I go to get my value here of cotangent theta equals 1, because again, in blue, you see I'm getting the trig function by itself. Now here's a little trick real quickly. When you see this 1, you think, oh, go up to your unit circle because that's where all the 1s and 0s live. But tangent and cotangent have two values of 1 in the special chart. So you got to be careful that you don't go right to the unit circle when you see a 1. You got to check out and see if it's tangent or cotangent, and it is. So I'm actually going to use the chart, special chart. Okay? I'm going to note my sign here, which here's positive, right? And that means I've got to realize I got to use tangent because the ASTC chart doesn't directly say cotangent, but it works the same for tangent as it does cotangent when you're talking about the positive or negative sign of the output for that function. So I do want the all because that's where tangent and cotangent are positive. I don't want sine in the second quadrant. I do want the third because that's where tangent's positive, and I don't want the fourth. So again, I note my reference here from the numeric portion. Cotangent's a 1. So again, you probably saw it when I drew before, that the reference of theta, the reference theta is going to be pi quarters. Okay? So I'll draw the pi quarters, and notice here that I do want that angle because I already planned for that I want the first quadrant angle. And I also want the fourth quadrant angle. Okay? So my theta answers here, like I said, will be pi quarters, as well as 7 pi quarters, using the pi quarters reference to generate a related angle in the fourth quadrant. So if you notice, I get these 4 answers, and they are the solution to that equation. So I hope this modeled some factoring with for you. If you are having problems in other problems along these lines, it might require a different style of factoring. Okay, so you have to be fluent in your factoring. You're going to need some Algebra 2 resources, not trig resources if you're struggling there. So enjoy, share, and work hard.